Assalamu alaikum students. Unit number 2, real and complex number, and it's exercise number 2.6 we'll have to start today. In exercise number 2.6, as we have just studied the complex number having two parts, real and imaginary, and it is written as a is equal to a plus b iota. Now before starting of exercise number 2.6, basic operations on complex number. As you know, when we study about number, we'll discuss their addition, subtraction, multiplication and division. So same exists in complex numbers, but how we add complex number, how we subtract complex number, and how we'll multiply the complex number will be the working in exercise number 2.6. So first, addition. Let z1 equal a plus iota b and z2 is equal to c plus iota d be two complex number, and where a, b, c, d belongs to the set of real numbers. The sum of two complex number is given by adding left hand side in the left hand side z1 plus z2 and adding right hand side a plus b iota into the right hand side a plus b iota plus c plus d iota. Now to add two complex number, we'll add real part into real part a plus c plus imaginary part into an imaginary part into iota. An example below will illustrate you how we add complex number. In the example, the two rational numbers are 3 minus 8 iota and 5 plus 2 iota. The real part is 3 and the real part of the second is 5. So 3 plus 5 will add, and the complex part is minus 8 plus 2 into iota. So the addition of these two complex number equal 3 plus 5, 8 minus 6 iota. The examples and we will discuss in exercise number 2.6 with very details addition, subtraction and multiplication. Now the second is the multiplication. Let z1 is equal iota a plus iota b, z2 is equal c plus iota d be two complex number. The products are found as k into a plus b iota, and if a number will multiply with that complex number, that it will multiply with real part and imaginary part as well. But when two complex number such as z1 and z2 will multiply, a into c, ac, a into d, ad and iota is common. B iota into c plus bc into iota, and b multiplied by d is bd iota square minus 1. So bd will be negative. I will explain you this example in the exercise where we will multiply the complex numbers. He has solved there. See that a will multiply with c plus d iota, b iota will multiply with c plus d iota, a into c ac, ad into iota ad iota, b iota into c bc iota, and b iota into d iota bd iota square, that is minus 1. So ac minus bd plus iota common ad plus bc. This is how we will multiply the complex numbers. And next, the subtraction. In the subtraction, it is same as addition, subtracting real part from real part and imaginary part from imaginary part. See, a plus b iota and c plus d iota are two number. We'll subtract them a minus c plus b minus d into iota. Now the division. z1 and z2 be two complex number, they will divide, and when there is a complex number in the denominator, we will multiply it with its conjugate, multiply and divide it with its conjugate. This is the division, because in complex number usually we not have a complex number in the denominator. So c minus d iota into c, a square minus b square formula, c square plus d square, and in the denominator the simple multiplication. We will see all these questions and their rules with examples in the exercise number 2.6. So let's solve exercise 2.6 now. The very first question, identify the following as true or false. Square root 3 multiplied by square root of minus 3 into square root of minus 3 is equal to 3. So students, let's discuss this true false, that why it is true and why it is false. Now square root minus 3 into square root of minus 3, true false. You must know if a statement is true, then how it is true, and if it is a false, the reason behind it. Minus square root 3 into minus square root 3, the answer is equal 3. Is it true or false? We'll check that. So students, there are two cases. I'm taking left hand side. Now if you see, when two square root sign multiply, the square root sign vanishes and the result ultimately minus 3. But on the other hand, if you multiply these numbers, when two numbers are multiplying in the square root sign, they will multiply as minus minus square root of 9, it is equal to 3. So it is a contradiction, because you multiply square root of minus 3 with minus square root 3. You said that square root sign will vanishes, remove. But on the other hand, when two square root sign multiply, their radicand also multiply. Minus 3 multiply by minus 3. So this is a contradiction. And what should be the right answer? Is it true or false? We'll have to check that it is false. It is false according to your book answers, according to board, that just you will multiply square root of minus 3 with square root of minus 3, it should result minus 3. Okay, we will not, if there is a cross sign, then we'll multiply in interior values. So the first one is false. The second one, iota power 73 is equal minus 1. Iota power 73. Let's check iota power 73. In 2.5 we have evaluate the values of iota. How? It can be written as iota to power 36, 2 multiplied by 30, 72 into iota to make it 73. As iota square is minus 1, minus 1 power 36 into iota. The minus 1 have even power, result would be 1. 1 into iota is equal iota. So it is false. The third one now, iota power 10, 2 power 5, it is true. You may check it. Complex conjugate of minus 6 iota plus iota square is minus 1 plus 6 iota. The complex conjugate, we are given with the number minus 6 iota plus iota square, and we know that our complex number have real and imaginary parts. So minus 6 iota plus iota square is minus 1. Now it is minus 1 minus 6 iota, and he has said that complex conjugate of, it means its conjugate of this is equal minus 1 plus 6 iota. It should be minus 1 plus 6 iota, but minus 1 plus 6 iota, yes, it is true. Then the complex conjugate is minus 1 plus 6 iota, it is true. Difference of a complex number and its conjugate is a real number. Okay, let's check it out. He said that difference of a, let z equal a plus b iota, then its conjugate will be a minus b iota. Their difference a plus b iota minus a minus b iota minus a plus b iota, a cancel with it, it is 2b iota. It is a complex part, so that will be wrong, because the difference of a complex number and its conjugate is not a real number, it is a complex number. If a minus 1 minus b plus 3 iota equal 5 plus a iota, then a equals 6 and b equal minus 1. It is related to the last question of the exercise 2.5. We will equate real part equal real part. A minus 1 equal 5. Minus 1 will be add in 5, so a equals 6. True. Similarly, b plus 3 is equal to 8 and minus b plus 3 would be, and it is 8 and minus 3 will add in it, b should be 11, so it is wrong. The last product of a complex number and its conjugate is always a non-negative real number. Let's check. Product of a complex number and its conjugate is always a square of non-negative number. Let z equal a plus b iota and z conjugate a minus b iota, their product now. A plus b iota into a minus b iota. A into a square. A into minus b iota, a b iota. B iota into a plus a b iota plus minus minus b into iota square minus 1. They'll cancel out, a square plus and b into b, that is b square is the answer. So product of a complex number and its conjugate is always a non-negative real number. Yes, it is true. So only the explanation of the definitions will be our topic today, and inshallah question number 2 will solve in the next lesson. Thank you so much.